Have you ever wished you could bottle up a sound? Not just the noise itself, but the feeling, the style, the essence of it.
That's a fascinating idea.
What if we could teach a computer to understand sound, not just as waves, but as a language with its own grammar and nuances?
You're talking about AudioLM.
That's right. It's Google's attempt to do just that, and we're taking a deep dive into it today.
It's definitely a groundbreaking advancement in AI. We're talking about generating human-quality audio using existing recordings as a guide. Imagine speaking in anyone's voice or composing music in the style of your favorite artist.
It sounds like something straight out of a science fiction movie. But how does it work? I mean, audio is incredibly complex. It's not just about replicating specific sounds, it's about capturing the emotion, the intention behind them.
Precisely. Think of it this way. A transcript of a speech only gives you the words, not the tone, the pauses, the inflections that convey the speaker's emotions. AudioLM tackles this complexity by using a two-pronged approach, employing both semantic and acoustic tokens.
Okay, I'm intrigued. Break those down for me.
Imagine reading a novel. Semantic tokens are like understanding the plot, the characters, the overall message the author is trying to convey.
So it's like understanding the meaning behind the sound.
That's a good way to put it. In audio, this means understanding the structure of a sentence or the melody in a musical piece. These tokens are generated using a pre-trained model called W2V-BERT, which has been fed a vast amount of audio data to learn these patterns.
What about the acoustic tokens then?
Acoustic tokens are where the magic truly happens. Think of them as capturing the narrator's voice, the tone, the pacing, the subtle inflections that bring the story to life. These tokens, generated using SoundStream, capture the finer details of the audio waveform, allowing AudioLM to replicate not just the what of the sound, but the how as well.
So if semantic tokens are the story, acoustic tokens are the storyteller with all their unique quirks and nuances. But how does AudioLM actually learn to use these tokens?
Here's where things get even more fascinating. AudioLM utilizes a hierarchical learning process involving multiple transformer models, similar to the technology behind language models like GPT-3. It starts by predicting the semantic tokens, essentially deciphering the basic meaning and structure of the audio.
Okay, so it lays down the foundation of the sound, figures out the message. Then what?
It moves on to the acoustic tokens. First, it predicts coarser tokens, like a rough sketch of the final audio. Then it refines these into finer acoustic tokens, capturing the subtleties and complexities that make the audio sound so real.
All this talk of tokens and models is making my head spin. But it's really impressive how AudioLM's not just mimicking sounds, but actually composing new audio that fits the context of the existing recording.
Absolutely. This is where the real power of AudioLM shines. It's not just about copying, it's about understanding and extending. For example, imagine a conversation where the last words of the recording are, and then I just don't know what happened next.
Oh, I get it. So you can actually continue a conversation.
Exactly. AudioLM can continue the conversation, seamlessly generating new audio that sounds like the same speaker, even replicating the background noise.
That's mind-blowing. So it's not just about mimicking a voice, it's about creating a cohesive, believable extension of the original recording.
Exactly. And it's not limited to speech. This audio continuation applies to music as well. Imagine a piano piece that abruptly ends, and AudioLM steps in to complete the melody, adding a new verse or even a whole new movement.
I can just imagine the possibilities for creating music this way, especially for composers who might have unfinished pieces or want to experiment with different styles.
It opens up whole new avenues for creativity, and not just in music. Imagine using AudioLM to restore damaged audio recordings, to personalize soundscapes for relaxation, or to enhance language learning tools by creating authentic-sounding voices for different languages.
Those are all incredible applications, and it makes you think about the impact this could have on fields like entertainment, accessibility, and even education.
Indeed, the possibilities are truly vast, and it's only a matter of time before AudioLM starts revolutionizing how we create, consume, and interact with audio.
This is all incredibly exciting, but it's also a bit daunting. We're talking about generating audio that sounds almost indistinguishable from real human voices or music. That raises some questions, doesn't it?
Absolutely. You're right, there are ethical considerations. We have to think about the potential for misuse. Could AudioLM be used to create convincing deepfakes? Could it be used to spread false information in a way that's even harder to detect than fake videos?
You're bringing up some really important points. It's easy to get caught up in the technical marvels of this technology, but we need to think about the consequences.
Luckily, the researchers at Google have been very thoughtful about this. They have already developed a classifier that can reliably distinguish between audio generated by AudioLM and real audio.
That's reassuring to hear. Even if our ears might be tricked, the AI can tell the difference.
Exactly. It's impressive. They're achieving a 98.6% success rate with the classifier. This shows that we can build safeguards against the misuse of AudioLM.
So we can relax a little. This technology is going to be used for good, right?
It's too early to say for sure. It will depend on the choices we make as a society. We need to think about ethical guidelines, transparency, and responsible development.
It's a constant balancing act between innovation and safety.
That's why it's essential to keep having these discussions and to involve the public in shaping the ethical landscape for AI technologies like AudioLM.
So what are the key takeaways you want our listeners to remember from this deep dive into AudioLM?
AudioLM is groundbreaking. It represents a huge leap forward in AI's ability to understand and generate human-quality audio. This has the potential to revolutionize many fields, from entertainment and content creation to accessibility and language learning.
It's almost like we're on the cusp of a new era of audio. Think about it. Symphonies composed entirely by AI, virtual assistants that sound like our favorite celebrities, and people communicating in languages they've never learned before, all thanks to the power of AudioLM.
That's the exciting and maybe a little bit unsettling reality of where we're headed. What will you create or critique as the lines between real and AI-generated content continue to blur?
That's the million-dollar question. Thanks for joining us on this deep dive. We'll be back next time with another fascinating topic. Until then, stay curious.